Hi, my name is Karan.
And I'm Rashab, and we are Team L.
The main motivation for our project was the 2008 market crash. During this time, individuals could not pay back loans due to bad debt. Home Credit, a financial institution, doesn't want history to repeat itself, and so they have hired us to explore the data. The main goals that we're focusing on are accurately predicting home loan repayment for current customers and further expanding the scope. So, building a classifier that can help identify defaulters from new applicants. This basically shows all the data that we worked with. One of the first things we did was data preparation and data cleaning. In terms of data preparation, we did a lot of join, set differences, and intersections. At the end, we obtained a final data set consisting of 23,000 rows and 112 features. The EDA here shows the class imbalance in our data, which was handled during cross validation. Over here, you can see that 90.47% of the applicants are not defaulters. This EDA shows the age distribution of the defaulters, and you can see that the younger the customers, the more likely to default.
We have divided our solution into 6 steps. Step 1 is one-hot encoding, where we are converting categorical variables into binary variables for our model fitting. Step 2 is dividing the data into 75 to 25% train test split. In step 3, we are doing hyperparameter tuning using cross validation. In step 4, we are passing the parameters obtained in step 3 with the models to find the best model. In step 5, we are performing matrix calculation over the models that we received from step 4. In step 6, we are basically repeating step 4 and step 5 3 times. One of the first things we are doing is not fixing any class imbalance or not adding features. Step 2 is after fixing class imbalance but not performing any sort of feature engineering. And finally, we are fixing the class imbalance and performing feature engineering where we are adding some domain features. One of the metrics that we came up with is cost. The idea is that for a manager at Home Credit, we want to make an easier metric for evaluating the best model. Here we are associating a cost of $90 on an average for a false negative versus $10 as an average cost for a false positive. And the goal is to find the right balance between opportunity cost and cost of accepting a potential defaulter. Here we can see model comparisons done over the 3 steps that we talked about. And in column C, we can see random forest performs the best on given two matrix AUC and cost. Here we can see 3 ROC curves. The left one is for the best model, which is random forest. The middle one is for naive Bayes, which is the worst model, and the default model is on the right. Here we can see top 10 features from the best model, which is random forest, and more details about it are covered in the report. At a cutoff of 0.48, we see the least cost, which is actually the best model where it balances false negatives and false positives. Here we can see that a recall of 0.82 is achieved, which is good for our application with an AUC of 0.66, which is a 32% improvement over the default model.
Finally, I'd like to discuss the business implications. I'd like to start off by saying that Home Credit is more risk averse and therefore is more likely to credit individuals with good credit history rather than crediting individuals with little credit history. I'd like to mention that the information gained from our assessment would therefore allow Home Credit to better evaluate these new applicants, and it would allow them to shift their utility function from being more risk averse towards being more risk neutral, as you can see from the left graph to the middle graph. And ultimately, this would result in their customer base increasing.
To summarize, we have divided our solution into 6 steps. We found the best model to be random forest using the cost metric and the AUC. Um, Having fitted the model, we achieved our initial goal of finding an optimal way of classifying default. Also, we found a good way of finding whether a person is going to default with minimal given history. This would actually increase the customer base and also improve an assessment model for the given customers. Thank you.